Isn't an illusion or a magic trick, although it's often passed off as one. It's nitinol, a bizarre metal known as a shape memory alloy that can be trained to remember any shape. It's been slowly gaining popularity over the past few decades, but it's about to be put through one of its biggest tests yet.
But shape memory is one of those things that I really believe is going to create a paradigm shift for the world.
Nitinol is an alloy made of nickel and titanium, and was first discovered by Dr. William J. Buehler in 1959 as he was looking for different alloys to use in the nose cones of missiles. But he noticed that nitinol had a very peculiar response to temperature and stress.
So shape memory alloys are governed by this principle of phase transformation.
Othman Benifon works with shape memory alloys at NASA's Glenn Research Center. He talked us through what's going on within the metal. Basically, he says all matter moves through different phases as it heats or cools, from solid to liquid to gas. But some materials can also go through different phases and remain a solid under extreme temperature or pressure. The elements are the same, but the arrangements of the atoms change.
So you really don't change the matter from solid to another liquid. It's a solid to solid phase transformation.
Lots of materials have this property, but in nitinol, the process can be controlled.
And the key to shape memory alloys is that this phase transformation is reversible. That is the key. That is why we have that name memory. So you can heat and cool and go back and forth. There's always a path to go from one state to another.
To train the nitinol, you heat treat it at 500 degrees Celsius in your desired shape, then quench it in cold water. Now, whenever the alloy's temperature reaches a threshold, known as its transformation temperature, it reverts back to the shape you trained it to remember. And there's more to nitinol than just the shape memory effect. It can also be super elastic. If the alloy is created to have a low transformation temperature, say below room temperature, then it's already in that phase of its final shape. So when we try to deform it, it bounces right back. By altering the ratio of nickel